So in this video, we're going to look at everything you need to know about vectors for your GCSE Maths exam. So we're going to start off by looking at basic vector questions like this one here. We're then going to look at how do you label a vector like this. We're then going to look at multiple parts, so getting a little bit more complex. And then we're going to look at properties of shapes, so parallelogram, hexagons, looking at parallel sides, so on and so forth. We are then going to look at midpoints, for what happens when you've got something like that. And then we're going to look at ratios, squashing to with ratios, and then proving parallel sides, like that question there. And then finally looking at proving straight lines. And as always, we'll wrap up with a real exam question. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. So looking at the first one, we've been asked to express AB as a vector. So reading this, there's an arrow at the top. It's going from A to B. Okay, that's important here. So on the diagram, we are going to go from A to B, and we can see to go from A to B in this direction, the answer is just going to be A, nice and easy to start with. So hopefully you press pause and had a go at this. So the answer here is going to be B. We are going from C to D. So if you look here, we are going from C to D. Now, moving on. Again, in this one, we are going from A to B, but it's a little bit different this time. So we're still going from A to B, but notice the arrow. The arrow is pointing in the opposite direction. We want to go from A to B that way, but the arrow is pointing backwards. So in that case, it's going to be negative A because we're going in the opposite direction. So again, hopefully press pause and go at this. We are now going from D to C. So on my diagram, I'm going to go from D to C, and I can see I'm going in the opposite direction to the arrow. So that answer here for D to C is going to be negative B. So now we want to go from A to C. A to C, so that's going to be A. And I'm going to go from here up to B and then to C. So this is going to become, so I'm going to go from vector A to vector B first, and then I'm going to go from vector B to vector C. So just to highlight that again, I'm going to go from here to here first. That's going to be A. And then I'm going to go from B to C, which is going to be B. So again, hopefully you've pressed pause and had a go at this one. So to go from C to D, C to E, sorry, I'm going to go from C to D first and then D to E, and I'm going to show my full working out. So C to D plus D to E, which is going to become R plus T. And with this one, just being careful with the direction of the arrows. We are going from A to C, so we're going to go from here to B and then to C. Now, we're going to write that out, the full vector form, so that's A to B, and then we're going to go from B to C, and that's going to be A to B is A. However, notice now, from B to C, going in this direction, the arrow is pointing the opposite way, so that's going to be not a plus, it's going to be a minus 2B. So again, hopefully you've pressed pause and I had to go at E to G, so that's going to be E to F first, and then from F to G, and then E to F is B. However, I can see this one's pointing the wrong way because we want to go down this way, but the arrow is the opposite way, so we use a negative sign. Now, being careful here, you have to put brackets around this because there's two points. We've got C plus D. So when you expand these brackets out, you will end up with B minus C minus D. Okay, that negative, you multiply it by the C and the D, and you end up with that answer. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. I've only put the final answers, but make sure you've put the full working out. So for example, here, this would have been P to Q, and then Q to R, and then underneath it, you would have written the vector. So now we're labeling the vector. So it says on the line below, draw A to B is A. So it's saying, well, go from here to here in that direction because it's a positive A. So that will just be A like that. And in the second example, hopefully you've pressed pause and had a go, we are going from C to D, and that is going to be an arrow there. That's B. Now here we are going from B to A, okay? Notice that it's B to A. So we're going from B down to A. We're going this way. So that is going to be my A. And in this one, we are going from D to C. So that will be in that direction. So that is B. So B to A is A. So B to A this way. Okay, so that's going to be A. And then the next one says C to B. So find C first, and then we're going to B, so it's in that direction there. So hopefully you've pressed pause and I've got the right one. So we are going from D to C in the first one. So we're starting at D, we're going to C, so it's going to point that way. And for the second one, we are going from D to E. So again, we're starting at D and we're going to E, so the arrow is going to be that way. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. So moving on to something a little bit more advanced now, but it's going to use the same thing we've learned before. We're going from A to C. So we're going from A to C, but notice we can't really go down this way because we don't know anything about this line. So we're going to go up and then down. So again, we're going to write the full answer out. So that's going to be A to B, and then we're going to go from B to C, which will become A plus B. And for this one, again, hopefully you've pressed pause and had a go. So we're going to go from E to G. We can't go this way because we don't know anything here. So we're going to go up from E to F and then F to G. And that's going to become, again, make sure you're writing out the full vector form. So that's E to F and then F to G. And that becomes C plus D. And just being careful with the arrows on this example. So we are going from F to G. So I notice that when I go from F to E, the vector's pointing in the opposite direction. And then I'm going from E to G. So F to E is going to be minus 2A. And then we've got the B. So now we are going from N to O. So that's N to O. I can see that both of these vectors point in the wrong direction. So that will be, well, I say wrong direction, opposite direction is what I already mean. N to M, and then M to O, and that is minus 3B minus, now we're going to use brackets here because there's two values, A plus B, and we're going to expand the brackets out, so that's minus 3B minus A minus B, and that can become minus 4B minus A. So we now have O to C. So to go from O to C, we're going to go up, there, and then there. In fact, I'll write this out down here. So we have O to C, O to A first, and then A to B, and then B to C. That's B, that's 2A, and that's A plus B. Now, just to tidy that up, that's the A's, so that's 3A, and then we've got the B's, which becomes 2B. And on the right-hand side, again, hopefully you've pressed pause and had a go. We are going from E to G. So we are going to write that out. E to H, sorry, is what I meant. E to H, so that's going to become E to F, and then F to G, and then G to H, which is going to be B plus 5A minus B plus 2A. Looking at the A's, that's 7A, and the B's cancel out, so we are left with 7A. So looking at this one now, O to B, how do we go from O to B? Well, we can't go down this way because we don't really know anything about this. I guess we could figure it out, but that just looks like an easier route. I already have that vector, so that's exactly what I'll use. O to B, which is going to be O to C plus C to B, which is B plus 3A. Now again, hopefully you've pressed pause and had a go at this, and you've noticed, well, I can't quite go down this way because I don't really know what this is. Can't go down this way either, don't know what that is, but I can see I can go down this way, so I'm just going to use that one there. So that's going to be O to B, which is going to be O to A first, and then A to B, which becomes A plus B. So with this one, again, it looks a little bit trickier, but the same concept applies. We're going from F to H, and I'm going to go like that. So F to H, I am going to go from, oh no, equals F to E, and then E to O, and then O to H. And then that would become minus 4A, because I'm going in the opposite direction there, plus 2A plus B, which becomes minus 2A plus B. And on the right hand side, again, hopefully you've pressed pause. Now to go at this, so B to C, I would go like that. So B to O, O to A to D, and D to C. So that is B plus, oh, no, not plus, minus 2A plus 3B plus 5A. And then we have the A and A, which is 3A And then we've got the b's, which is plus 4b. So looking at this one here, we are going from O to T. Now to go from O to T, we can go this way and then this way. So that will just become O to T is O to A plus A to T, which is minus B plus 2A. And on the right, again, hopefully you've pressed pause and had a go. To go from G to T, we can't quite go this way. We don't know what that is, but we can go that way. So G to T, I'm going to go from G to E first, and then I'm going to go from E to T, which is B plus 2A. So here's some practice questions for you to have a go at, press pause and have a go. Here are the answers. Make sure you've shown the full working out. I've only put the final answers in here. And yeah, moving on. So we are now looking at vectors with multiple paths, where a vector might be given and not shown. And you can sort of see, I've put that at the bottom of the slide so you know what kind of example it is. So reading this question, it says O to A. Let's label that on. So it's saying going from O to A. So that's that direction there. Making sure we get the direction right. That's A plus 2B. The question tells us that right here. And then it's saying find BC. So if we're going, I can't go this way. I don't know what that is, but I can go this way. So I'll use that route. So now B to C is B to A plus A to O plus O to C, and then B to A is minus 3A because I'm going in the opposite direction. And now here, it's again, be careful because there's two values, so we're going to put it in brackets just to make sure we don't mess the signs up, and plus 6A. Okay, so now we're going to expand the brackets out. Now we're going to collect the A's, so that becomes minus 4A plus that, which is 2A minus 2B. Now on the right, it tells us AB is equal to 4 times OC. Well, what is OC? Well, we can see OC is equal to A right there. So if AB is 4 times that, that would just be 4A. So let's label that on. So A to B, make sure it's labeled in the right direction. That's 4A. Now we need to find C to B. Well, it's same as before. We can't go this way. We don't really know what that is, but we can go this way. Not O to C, that should say C to B. C to B is C to O, and then O to A, and then A to B, which then becomes minus A minus B plus 4A, which to tidy that up becomes 3A minus B. So with this one, we are told T to O is A, so going from T to O in this direction is A, so we're going to label that on. And it's asking us to find T to B. Well, I can't quite go down this way. I can't go down this way because I don't know what that is, but I can go down that way. That seems the easiest, so let's just do that. T to B is going to be T to O plus O to A plus A to B, and that would be A plus A plus B. I'm not used to brackets here because it's a positive sign. We're going in the same direction, so we don't need to worry about the bracket, and that would be minus B. And now to tidy that up, that would become 4A, and the B's would cancel out. So again, on the right, we've been asked to go from T to B, but this time we've been given T to A. So T to A is given as B, which means you can just go that way. And again, we can write the full answer out, which is T to A, show all are working out. Sorry, T to B is T to A, and then A to B, and that is B plus 3A. So here's another one. So we have A to C this time. So to go from A to C, we can see the easiest way is just to go down that way. So we will go A to C is going to be A to B plus B to C, which is going to be A minus 2B. And then it also wants O to A. So to go from O to A, we can just go down this, that, and that. So that would be O to C. Oh, let me just change the color back. O to C, and then C to B, and then B to A. So that means I start at O and finish at A. which is a plus b plus 2b, and then we're going in the opposite direction. The a's cancel out, that becomes 3b. So on the right hand side then, we have that question. Hopefully you've pressed pause now to go. Let me move that out of the way. So O to n is equal to a to n. Okay, so these are both equal to each other, so that must be a as well. And then it says b to n, find b to n. Okay, so b to n, that way. So b to n is b to o plus o to a plus a to n, and that is negative b plus 2a. So we are now looking at properties of shapes. So here we have parallelograms. It's worth bearing in mind with parallelograms that they have two pairs of parallel sides. So this side and this side are the same size. So if this is b, this is also b, and this side are the same. So because we know what AB is, we automatically know that's also b, and that's going to be a. Okay, so just remember, parallelogram has two pairs of parallel sides. So that is parallel to that, they're the same. That is parallel to that, so they're the same. So that means our answer, OC, we already have, is equal to b. So on the right, we have no labels given. Let's read the question. So OA is b. So like I said, if you know what this is, you automatically know what this is. They're parallel. And it says AB is 2A. So A to B is 2A, which means I automatically know what this is. Nice. And then the question saying, what is B to C? So it's saying, well, how do you go from B to C in this direction? Well, because we're going in the opposite direction, B to C is going to be minus B. And in fact, you could have even gone down this way and gotten the same answer. So we then have hexagons. So again, hexagons, same thing applies. This is parallel to this. And then we have that is parallel to that. And then we have that is parallel to that. So if I just label on what I know, that is parallel to that, which is that, and which is that. We don't have any information about this or this side, so we can't do anything there. So the question is asking what is C to D, and you can see I've already done that there. And I found that out from this line here. And if I look over on the right, the question is asking for C to O. Again, hopefully you've pressed pause and had a go at this. So again, I'll start off with the rules I just said. Sides are parallel, so that side is the same as that side and that side. Okay, so it's worth bearing that in mind that in fact, even that is the same. All three of these are A, so I'll label them on. So that is A, and that is A, okay? All of these are parallel to each other and they're the same size. Now, we'll do the same with B. That's B, and that's B. In fact, I'll zoom in. Okay, so now the question is asking, how do I go from C to O? Now, we can't quite go down this way because we don't have any information, but what we can do is go from here to here and then here to here because we do have that information. So we can go from C to O, is going to be start at C, go to B, and then from B, go to O. Now, C to B is B, and how do we know that? From this one here. So that's B, and then B to O is minus A, and how do we know that? From that one there. So that is going to be negative A. So here we have a parallelogram. The diagonals intersect at O. Right, so as I said, with parallelograms, both sides, sort of two sides are parallel. So that is parallel to that, and then that is parallel to that. So looking at this, it's asking for A to C. So how do you go from here to here? Well, we can go down this way and then this way, but now you might be thinking, well, we don't quite know what that is. Because they're both crossed at the diagonals, we know it's exactly halfway, so this must also be A. And equally speaking, this will be B, okay? So this line is going to be the same as this line, and then this line is going to be the same as this line. So we now know that A to C is just going to be, well, you can go from A to O, and then O to C, which is negative A, which is negative 2A. Okay, so we're just going down that. So hopefully you've pressed pause now to go at the example on the right. Let me just make sure this isn't zoomed out too much. Nice. So it's saying, how do you go from A to D? So this is what it's asking for. Okay, so, well, I don't know how to go down this way, but I can go this way and then this way, but I need to add the labels on first. So that is B, as we know, because they cross at the diagonals. That is equal to that. So that means I'm just going to go take that route, which is going to be A to O, and then I'm going to go from O to D, which is negative A. Oh, no, it's a negative B as well. There we go. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. So we're now moving on to midpoints. So midpoints are basically just points halfway through the line, as the word suggests. So in this question, we've been told A to B is 2A. So what it's saying is that this full length, oh, I wasn't supposed to use that. There we go. This full length is 2A. And then what is half the length going to be? So if I just draw that underneath, actually here. So what it's saying is, well, this full length is 2A. M is at the midpoint. What is half of this length going to be? Well, if the full length is 2A, half of it must be A, because two halves will join together to make the full. So you can see that the full length is 2A, half of it's A, this half's A, this half's A, and you can add these two halves together, and when you add these two halves together, you end up with 2A. So the question's saying, well, what is A to M? And, well, you can just say it's A, but it's basically half the full length, because it's midpoint, which is half times what is the full length? 2A, which is A. So just half the full length. Whenever you ask for the midpoint, just half the full length is the easiest way to remember it. So here, for example, the full length is given as 10A, which means this half must be 5A, this half must be 5A, and then if you read the question, he wants M to B, so the question's interested in this bit, and you can see that's just going to be 5A. So we now have A to B as 6A. So again, remember the full length is given as 6A, which means this half is going to be 3A, and this half is going to be 3A. The question is asking for B to M in this direction, which is just the opposite direction. So we can just say, well, B to M is just going to be negative 3A. And again, if you look at the one on the right, it's saying, well, M to A. Well, actually, we've been given A to B as A this time. Okay, so A to B, the full length is A. So half of that must be half A. So this is a half A. And this is a half A. And then the question's saying, well, how'd you go from M to A? So starting at M, we're going to go in this direction, which is the opposite direction to that. So that's going to be MA is equal to negative a half A. And now we have A to M. So the question, it's worth reading the question carefully here. They've told us A to M is 2A. We know M is a midpoint. The question tells us that. So that means this other half must be the same because it's midway through. So it's saying find AB. Well, if half of it is 2A, then the full bit must just be, well, you can sort of see that from there. That's going to be 4A. And on the right, we have M to B is 6B. So obviously the other half must be, and the other half's always going to be pointing in the same direction, okay? So that's saying, oh, what's AB? So yeah, AB is just going to be both of them added together. So that's 12B. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. So moving on, we are now looking at hard examples with midpoint. So similar to before, remember just midpoints are just half the full length. So the question wants A to M. So the question is interested in A to M. And now we know A to M is just going to be half the full length, which is going to be A to B. The direction is important, right? A to M, which means we're going to have half of A to B. It must start at the same letter, okay? Always, because we want it to point in the same direction. Do we know what AB is? Well, yeah, the question tells us AB is 2A. So we know that this full length is 2A. So half times 2A, which is just going to be A. So on the right, we know that AB is, we can label that one straight away, 5A. It's asking for BM. Again, if it does help, you can always sort of label and say, well, this is 2.5A, and this bit here is 2.5A. And now the question saying, well, how do you go from B to M? So to go from B to M, we're heading in this direction, which is the opposite direction to the vector. So B to M is going to be minus 2.5A. So slightly more advanced, but we're going to, work it out the same way. So M is a midpoint. The question's saying I'll find AM. Remember, whenever we ask to find half a length or a proportion, just half the full length. So if I half the full length, so it's asking for A to M. Let's just get the full length and half it. So AB. Now, do I know what AB is? No, but can I figure out what AB is? Yeah, because I can just get it like that. So on this side, I'll just say, well, AB, I can go from A to C and then C to B. And that's 3B plus 4B, which is 7B. Now I can substitute that into there. So that's going to be a half times 7B, which is 7 over 2B. Okay, you can leave it as a fraction like that. So again, hopefully you've pressed pause and I've got an example on the right. So the question's saying find AM. So it wants half the length of that. So the full length here is going to be AB. We're going to half that to get AM. So AB is what? So to get AB, we can go from A to C and then C to B. So we're going to go from here to here, here to there, and then that gives me A plus 2A, which is 3A, and then we can just substitute that here, which is 3A over 2. So moving on, and remember properties of shapes, yeah? They're parallelograms. Two sides are parallel, so we know that if this is B, this is also going to be B. So I'm just going to write that on here. So, well, to be more precise, these two are midpoints. So the question doesn't say it. I must have forgotten to write it, but X and Y here are both midpoints. So given that X and Y are midpoints, we can say that, well, this must be a half B, and this must be a half B, and then that, if I just zoom in a bit actually, this must be a half A, and this must be a half A. Using the properties of parallelogram, this side is parallel to this side, so if this is A, this must be a half and half, because there's a midpoint, and then if this is B, this must be B, which means this half is half B, this half is half B. So to get our answer, B to X, so to go from B to X in this direction, I'm going in the opposite direction to the vector, so that's going to be minus a half A. And then to get O to Y, let me just make it clear that that's Y or not X. There we go. O to Y. So go from O to Y, that's just going to be a half B. It's in the same direction as the vector. So hopefully you've pressed pause and had a great example on the right. So if I zoom in a bit again, so we are told in here that AB is, so A to B is 3B. So we know that this, since it's a parallelogram, these two are the same. O to C is equal to C to N. Okay, so we know that this is equal to this. So because M's halfway, this must be 1.5b, and this must be 1.5b. Now the question's saying, well, how do you go from C to M? Now, it's just going to be 1.5b, so we can just say, oh, that's 1.5b. So moving on, we have M as a midpoint. Now remember, when you ask to find a midpoint, find the full length and half it. So we're going to use that same approach. We're going to say, well, AM is going to be half the full length, which is A to T. Now all we need to do is find A to T. So to find, I'm just going to zoom in a bit because I think I'll need the space. So to find A to T, I can go from here to here, and then here to here. But then you might be thinking, well, actually that's missing. The only other thing I could do is go here to here and here to here, and that's missing as well. But I know in the question that T is also a midpoint. So what I'll do is, I can pick whichever one. I'm going to go up this way. So O to A plus O to T. Now A to O is B. Now I don't know what O to T is. However, I know that T is a midpoint. And remember, like I said before, whenever you're looking for a midpoint, so O to T is just going to be half the full length. So O to T is just half the full length of O to B. So now I just need to find O to B. But I can find that because to go from O to B, I can go this way. So I'll just do that in here. So to go from O to B, that is going to be minus B plus A plus B. And to tidy that up, that just becomes a half A. So now I know what O to T is, which is that there. I can substitute that into here. So that's going to be a half A. So now I know what A to T is. I can substitute that into here. And then that becomes a half bracket B plus a half A. And that becomes a half B plus 1 over 4A. Okay, this one might have seemed a little bit more advanced, but hopefully I went through that step by step. The first step was, well, we want to find A to M. So we're going to start with finding the full length and halving it. So then I wrote A to T, but then we realized, well, we can either go this way or this way. Whichever way you pick, this bit was missing or this bit was missing. So we decided to go this way. It doesn't matter which way you go. But then we went that way and that way. We needed OT, but then again, T is a midpoint, so we needed the full length. So we got the full length, which is here, O to T, we halved it, which gave us that, and then we substituted that back in. So press pause, now I've got the example on the right. So we need E to M. Again, it's a midpoint, so we can say, well, E to M is going to be a half E to F. And I can also see the question's giving us some information. So it's saying T to F is 3 times G to T. Do I know what G to T is? Yeah, okay. Yeah, let's use the information given there. So E to G plus E to T. That's going to be B plus 2A. Okay, so we know what this is. B plus 2A. In fact, let me just move that down a little bit so it's not. And let me just write that properly so it looks like an A and not a 9. There we go. And we know that this is just 3 times that because the question tells us this. So that's going to be 3B plus 6A. And again, let me just move that down a little bit. Okay, so we need E to F. So how do you go from E to F? Well, to go from E to F, you just go down this way and then this way. So that becomes, in fact, I'll just do it in here. So E to F will just become E to G, which is negative B because we're going in the opposite direction, plus B plus 2A plus 3B plus 6A. And if I tidy that up, I can see them two cancel out. So that leaves me with 3B plus 8A and then a half outside. We can expand it out or just leave it like that. So that becomes 3 over 2B plus 4A. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. So now we're looking at ratios. So before we looked at midpoints, which we knew as soon as you see the word midpoint, we're just going to halve the full length. Now we can also have ratios. So when you see a ratio of 1 to 1, it's the same as midpoint. So if I write that as a fraction, so to write a ratio as a fraction, I'm going to add the ratio together. So that's 1 plus 1, which is equal to 2. So that's going to be 1 over 2 and 1 over 2. Okay, so you can see where the 2 came from. I added them both. Oh, I wasn't supposed to do that. I added them both together. That's where the 2 came from. And the 1 is what was already in the question. Okay, so that's basically saying, well, A to X is a half. And A to B, X to B, sorry, represents a half. That's what the question is essentially saying. So then it's saying, well, find A to X. So I know that A to B, the full length is 2A. So A to X is just going to be half of that. So we can say, well, A to X is just going to be a half of the full length according to that ratio. So it's going to be half of AB. We know that AB in the question is 2A, which then becomes A. So again, looking over to the right, we're going to add the ratio together, 1 plus 1, which is 2. So that means the total 1 to 1, which can be written as a fraction, 1 over 2, 1 over 2. Now we know the full length is 4A. And we know that A to X is half the full length. So we can say, well, A to X is a half the full length, which is AB. Well, it's 4A. So we can say half 4A, which is 2A. Now, obviously, ratios won't come in usually as 1 to 1. They'll be written as something different. So, for example, we've got 1 to 2, but step 1 is the same. Add them together. Step 2, label them. So we know A to X is 1. X to B is 2. We're going to write that as a fraction, so divide it by the total. we know that the full length is 3a. Now the question is saying find a to x. So we can see that a to x is 1/3 of the full length, which is 1/3 of ab, which becomes 1/3 3a, which becomes a. So again, press pause and have a go at the example on the right, add the ratios together. That gives me the total, label the ratios. So it's saying a to x is 1, and then it's saying x to b is 3. So we can write that down. That's 3. Divide that by the total. And what else does the question tell us? Well, it tells us that the full length is 4a. So that means a to x is going to be 1/4 of the full length, which is a. And again, so we have a to x, x to b. So this time it's a little bit different because they haven't told us the full length. What they've told us is x to b. They've told us what this bit is. So we're not going to work out the fractions for this. We're going to write, well, a to x. In the question, it says a to x is x to b in the ratio 3:4. And as a vector, x to b is 12a. Well, how do you go from here to here? Well, they must have times it by 3a. So if you multiply this by 3a, you get 9a. So the answer, a to x, is 9a. So this was nice and easy. And again, if you look over the right, they haven't given us the full length, they've given us xb. So again, we're going to see, well, a to x, x to b. So as a ratio, that's 1:5. X to b is 10a. So they must have multiplied this by 2a. So we'll do the same here. And the answer is 2a. So a to x is 2a. So here's some practice questions to have a go at. Press pause and have a go. Here are the answers. Mark your work. So we are now going to look at questions to do with ratios. So I'm just going to zoom in here because I might need a bit more space. So we have x is a point on AB. We can see that. We have a ratio and they've given us the full length. Because they've given us the full length, what we'll do to start with is find the total of the ratios, which is 3. We're then going to label them on. So a to x is going to be 1. X to b is 2. We're going to write them as a fraction. So divide them by the total. Now the question is saying, well, what is a to x? Well, we know a to x is 1/3 of the full length, and the full length is a to b. So we can do 1/3. We know what ab is. They've told us in the question. So that is 2a. So again, press pause and have a go at the example. So we can see they've given us the full length here. They've asked us for ax. So given that we have the full length, we're going to add the ratios together. We're then going to write the ratios on here. So that's 1 to 4. We're going to divide it by the total to write it as a fraction. And now the question is saying, well, what is a to x? Well, it's going to be 1/5 of the full length, which is 1/5 of AB, which is 10a, which then becomes 2a. Moving on, we have axxb, and it's asking us to find x to b. So let's add the ratios together, which is a 7. So that is 3 to 4, writing that as a fraction becomes that. So same thing as before. A to x is going to be, well, no, it's asking for x to b, sorry. So x to b is going to be 4/7 of the full length, which is going to be a to b. The direction matters here because we're going from here to here. The full length is going to be from here to here. Okay, so now all we need is AB, and we've solved the question essentially. And AB is nice and easy. It's just that. So AB is A to C and C to B, which is 4B plus 10B, which is 14B. And now I'm just going to substitute that back in there, and I've solved the question. So 4/7 times 14b, so that becomes a 2, which becomes an 8, so that's 8b. So hopefully you've pressed pause and had a go at the example on the right. So the total here for the ratios is going to be 4. I'm going to label that on, turn that into a fraction by dividing it by the total. The question is saying, well, what is a to x? Okay, so we know a to x is going to be 1/4 of the full length. So that's 1/4 times AB. Well, what's A to B? AB is just that. I'm going to skip a step here just to save a little bit of time. So that gives us 3A, okay? But make sure you do show this bit of working out here on how you found AB. They are marks for method. So here we have a parallelogram. And again, it's just worth remembering the properties of a parallelogram. So as soon as you see a shape and you know the properties, just label the stuff on. So you know that's B. You know the full length here is A. And you know it's in the ratio of 2 to 1. Oh, I'll do it inside here actually, there's a bit more space. And if you divide that by the total, that's 1/3 and 2/3. And it's asking for C to X. So you know that C to X is just going to be 1/3 of the full length C to B. And well, you know what the full length is. It's A. So your answer is just 1/3 A. So again, hopefully press pause and I'd go at the example on the right. So we know that A to B is 3B. It's a parallelogram, so that's also going to be 3B. I can see that O to C is C to N. It tells me that in the question, so that's also 3B. And the ratios are 2 to 5. If I divide that by that gives me a fraction. So the question is saying, well, what is X to N? That is 5/7 times the full length, which is 5/7 times 3B, which is 15B/7. Moving on. So here I am told O to A is A to N, so O to A is also going to be A, and O to T, T to B, and divide that by the total. Cool, so it's saying, well, O to T is what I need to find. Okay, so to find, I'll use space here. So O to T is a small part of the line, so I need the full length, and multiply it by the fraction, so that's going to be 1/6 of the full length. Now all I need is OB, and I've effectively solved the question. So, well, what is OB? So to go from O to B, I can go from O to A, then A to B, which is A minus B, and the answer here is just 1/6 A minus B. So hopefully you've pressed pause and had a glad example on the right. So P to T, O to A is A to N. Let's label that one first. Then let's label the ratios on. Let's divide them by the totals, so we've got the fractions. And the question is saying, well, what is A to T? Now, A to T is a small part of the full line. So, well, what part is that? It's 4/7 of the full length. There we go. As soon as I've got AB, I've solved this question. So, well, what is AB? So, AB, well, how do I go from A to B? So, let's see, A to B. I can't go that way. I don't know anything here. I could go that way, and actually, I don't know anything here. Well, actually, there we go. That's nice and easy. So I'm going to go from A to O, and then O to B. There we go. I now know what that is. I know what AB is now. I can substitute that in there. And we can just leave it at that. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And now we are going to look at proving parallel vectors. Well, how do you prove vectors are parallel? You just need to prove that they are multiples of each other. So here you can see, well, to go from here to here and here to here, we've just multiplied by 2. So we can say CD is equal to 2AB. And that is how you prove vectors are parallel. You just need to prove that they are multiples of each other. And then you can just write a statement that says CD is a multiple of AB. Okay, so I'm not going to write that out just to save us a bit of time. So again, looking here, prove these are parallel. Well, are they multiples of each other? Well, yes, to go from here to here and here to here, I'm multiplying it by 3. So we can say that GH is equal to 3 times EF. And then again, same statement here, that GH is a multiple of EF, therefore they are parallel. And then you'll have questions like this, where it's essentially saying, well, prove AC is parallel to MN. So the first thing you need to do is find AC, then find MN. So let's do this. So A to B, we have been told M to N and N are midpoints. A to B is A. Okay, let's deal with that first. So that means this is going to be a half A because N is a midpoint. Okay, and then B to C is B, but then we know that M is a midpoint, so it's going to be half B and half B. Okay, and now, well, what is A to C? So to go from A to C, I can just go like that. And then what is N to M? N to N, I can just go like that. N to B, and then I can go from B to M. And that is a half A plus a half B. And hopefully you can see that this is just half of this. So we can then say that AC is equal to 2 times NM. And they are now multiples of each other. And then you would write a statement that says AC is a multiple of NM, and therefore they are parallel. Okay, we've proved that they're multiples, which is proof that they're parallel. So again, hopefully press pause and add a correct example on the right. So we have A to B is 5A, D to A is 2B minus A, so that's this length here. Okay, so that is 2B minus A, but M is a midpoint. Okay, so that means that this is going to be in 2 bits, so there'll be that bit there and that bit there, and I'll have to essentially half that. So if I times this by sort of a half, that would give me what the midpoint works out as, so that would be B minus a half A here, and then B minus a half A here. And then we know that the ratio here is 2/5 to 3/5. And we need to prove that N to N is parallel to C to B. I'll color them both in blue. So there we go. So we need to prove that these two lines are parallel effectively. And the way we do that is just prove that they're multiples of each other. So the first one is, well, how do you go from M to N? So to go from M to N, we are going from N to A, and then we are going from A to N. So to go from M to A is quite easy because we already labeled that. Well, how do you go from A to N? Well, A to N is some ratio of the full length. What is that ratio? Well, as a fraction, that's 2/5 of AB. So if I know what AB is, I've solved this bit at least. So, well, what is A to B? Well, how do you go from A to B? I can just do that. Actually, there's one other bit in the question I didn't read. Oh, there we go. A to B, I know what that is, 5A. So if A to B, I can just write that here. If A to B is 5A, I can tidy that up. And then we have, so that becomes 1.5, so that's 3/2A plus B. And now all I need is C to B. So C to B is going to be C to D plus D to A plus A to B. So I already know what A to B is. It told me in the question. It's 5A. I know what C to D is. It's going to be minus A. And D to A is just going to be 2B minus A plus that. So if I look at the A's, that becomes a 3A plus 2B. And now if I compare these two, you can see it's just a difference of 2. So to go from, so CB essentially is 2 times MN. The minute you've written this, you've proved that they're multiples. And because you've proved that they're multiples, that's also proof that they're parallel. And then you can just write a statement that CB is a multiple of MN, therefore they are parallel. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, proving that A, B, and C lie on a straight line. So we have this example here. Again, start off in the exact same way. Are they multiples of each other? Yes, that's times 5. That's times 5. So I can say that BC is equal to 5 times AB. Okay, so then I need to write that AB is a multiple of BC, so they are parallel. Now to get the next mark, you have to write they both share. Now they both share 1 point in common, and in this case it's B. They've both got B in common, so they both share B in common. This gets you the second mark. So A, B, and C lie on a straight line. Okay, you have to write all of that to get the marks. So hopefully you've pressed pause and I'll go at the one on the right. So the first step is noticing that it's a multiple of 4. So EG is equal to 4EF. Now I'm not going to write all of it out again, but again, you'll be writing that EG is a multiple of EF, right? Therefore, they are parallel, just like we've written here. And then you're going to say, well, they both share a point in common. So in this case, they both share point E in common, and therefore E, F, and G lie on a straight line. Okay, you need to write all of that out to get the marks. So with this one, I forgot to add this bit of information on, so it's worth bearing in mind that this shape is a parallelogram. And if I zoom into this, it's asking me to prove that DEF is a straight line. So before we do this, I'm just going to point out that we have some sort of straight line like this, DEF. Now, in order to prove it's a straight line, we need to make two vectors out of this that have a point in common. So what does that mean? So for example, I can look at D to F and D to E. I need to work them out, prove that they're multiples of each other, and they both must have the same share 1 point. So I could do D to F, that works. I could also do D to F, and I could have done E to F because now I have F in common. But just remember, whatever pair you end up picking, there's only 3 possible combinations you can have. You have to have a point in common. I normally tend to use the full length, which is something like D to F, and then I end up using either E to F or D to E, whichever one you prefer. So in this case, we're going to use these two. So essentially, we need to solve what D to F and D to E is. Now, given this is a parallelogram, we know that's 6A. We know that F is a midpoint, so that's 6. That's going to be, sorry, that is 6C. That is A. That's 3A. And that's 3A. And we know that this is 2/3 and 1/3. So if I start by finding D to F, that's going to be D to C and then C to F. So that is that. So that's 6C plus 3A. That's that done. Now I need D to E. So that's going to be 1. Sorry, that is going to be D to C again plus C to E. So that is that, which is going to be 6C. Now C to E is 1/3 of the full length, CA. So now I just need what CA is. So what is C to A? Well, I can see that C to A is just that, which is C to D. That, which is 6C plus 1/3 minus 6C plus 6A, which then becomes 6C minus 2C plus 2A. And if I tidy that up, that becomes 4C plus 2A. And I can see that DF and DE are multiples of each other, because to go from here to here, I just need to multiply it by 1.5. So what I can say is that DF is 1.5 DE. So I've proved that they're multiples of each other. So then I would write that DF is a multiple of DE. So they are parallel. And then you would say they're both share point D in common. And then so that D, E, and F are on a straight line. So hopefully you've pressed pause and had a go at the example on the right. We need to prove that M and C is a straight line. So the vectors that I'm going to use are the full length, which is going to be N to C, and I'm going to use N to N. Now you can pick whichever ones you want on the line, but just make sure they both share a point in common. Whatever vectors you use, you can either use this and the full length, or you can use this, or you can use this and this on its own, or the full length and this bit. It's completely up to you. But just make sure they have a point in common. So again, if I zoom in and I look at the question, it tells me a to n is 2b. And I know it's in the ratio 2 to 1, which means this must be b. And it also tells me that b to c is ab. Okay, so if we'd solve this with n to c first, that would just be that. So that just gives me n to a to b, b to c. That is going to be minus 2b plus 2a. So that's that done. And then the other one is n to m. So to go from n to m, I am going to go from, so I've been told m is a midpoint, so I'm going to go from n to d. And then I'm going to go from d to m. And I know that n to d is b, and d to m is just going to be half the full length, d to b. So I just now need to find d to b, and I've solved that bit. So d to b is, well, to go from d to b, I can just go that way. So that's going to be minus 3b plus a. So if I come back here, and if I expand that out, and I can see that in order to go from here to here, I just need to multiply it by 2. In fact, not 2, by 4. Yep. So NC is 4 times NM. And again, it'll be the same statement. So I'll just vocally say the statement. So it'll be NM is parallel to NC because they are both multiples of each other. They both share point N in common. So N, M, and C lie on a straight line. You need to write all of that to get the marks. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. And finally, we're going to look at missing ratio examples. So these are the hardest type of questions that can come up. But just looking at sort of both of these to start with. So if we read the question, we have a triangle. M is a midpoint. We know that O to A is A. O to B is, so we know this full length is B. O to P, 3/5, and that's going to be 2/5. So far, I'm just reading the question and labeling what the question's told me. Work out the ratio O, N, and B. So I'm going to label this X, and if that's X, this must be 1 minus X. Because we don't know what it is, so that's what the question wants us to find out effectively is, well, what is this and what is this? Now, in order to find missing ratios, you're going to use another straight line to form an equation that you don't know anything about. Now, the only other straight line here we don't know anything about that touches this line is this one here. We don't know anything about this. So we're going to use this line is going to be key to solving this question. And if I zoom over on the right-hand side, in this kind of question, when you do come onto it, you're going to use this line, this straight line that passes through the line you're interested in to solve the question. But we'll come on to that. So if we just focus on this for now. So the line we're going to use to solve this is that line there, and you'll see why. So we know, what do we know about this line? Well, we don't really know anything, but we can say that the full length, A to N, is going to be some multiple of A to P. Okay, so we can just write that out. So I'm saying the full length is going to be some multiple of this small part. So what I can now say is, well, what is A to N? So A to N, how do you go from A to N? Well, I can go this way. So that's going to be minus A plus XB. And in fact, I'll write that out with the full working out. So that is going to be A to O plus O to N. So I now know And I'll use the highlighter as well because this is quite a difficult question. So I know that a to n, which is that one there, that's what a to n is, okay? And now I need to find out what is a to b. And we can use that to form an equation then. So how do you go from a to p? So to go from a to p, we can go this way and then this way. So a to b is going to be minus a plus, it's going to be 3/5 of the full length. So that's going to be 3/5 of, well, actually, in fact, I'll write this out with the full working out what we're doing. So a to o, and then o to p. A to o is nice and easy. O to p is going to be 3/5 of the full length, o to m. So, well, what is o to m? We can figure that out down here, I guess. O to m is o to a plus a to m, which is a plus a half minus a plus b, which is a half a plus a half b. Okay, so we now know what that is. We can substitute that in. That's 3/5 half a plus half b. And if we tidy that all up, we'll end up with minus a plus. So we have o to m. Let me just read that again. That gives us that. And then we also have a from there. Then we have a minus a half a, which gives us that. Yep, cool. That makes all sense. 3/10a plus 3/10b. And then if we tidy that up, awesome. If I get my color out again. So just so we have visuals on where the blue stuff relates to. So now that we've done this, you might be wondering, well, okay, I understand. I can sort of see what we've done, but why does any of this matter? And how are we going to figure out what x is? Well, we're now going to sort of look at that equation that we wrote at the top. So we wrote that a n is equal to k a p. Okay, so if I look at if I use a different color here, in fact, if I just look at a first, a in that one and a in that one, so we can say, well, for a, in fact, I'll use a red color as well. So you can see the red color refers to what I've just underlined in red. So we can see for an, we have -1. We're not going to write the a, but we're writing the equation for a. And on the right, for ap, we have k, and we have this here, which is minus, well, it'll be times -7/10. So we can say that k is equal to 10/7 for a. And now we can write an equation for b. I'll use a different color. I'll use a blue. So that's this blue here, and that's this blue here. So if I just circle that, that's that and that. And I can say that, well, for b, we have, if you look at an first, so that's going to be x is equal to k times 3/10. The k, remember, we are referring back to this equation here. So what I've just said here is, well, the an is going to give me the x for b, and for the ap, I'm going to get the 3/10. And we already know what x is, so if we substitute that in, we end up with x is equal to 10/7 times 3/10, which gives us 3/7. So we've just found essentially what x is as a fraction. So we know that is 3/7 as a fraction, which means if the total of the fraction is 7, well, we can even subtract it from 1 and just say, well, it's that. And then that means the ratio is 4:3. So that is how you solve a question like this. So again, press pause and have a look at the example on the right. So I will zoom in here. And the question is asking us for a missing ratio in some sense, because it's asking us for what is that bit. So we can figure out what KAB is. So for this one, the same thing again. Let's have a look. AN is 2OA. In fact, let me just use this color. That's A. That's 2A. That's just by me reading the question. That bit there, that bit there. OB. Well, we know that that is B. Well, we know this is just going to be a half B. This is going to be a half B because that's a midpoint. Okay, and it's asking us for, what is this bit here? Again, we label it x. The bit we need, we label x. We'll call this one minus x. And now to solve a question like this, you want to look at a straight line that either touches it or passes through it that you don't know anything about. So in that case, the question actually even says it down here. It says, given that NPN is a straight line. That is a hint, because we're going to use NPN to form an equation. So I can say that MN, which is the full length, is going to be K times, what's going to be easier? I'm going to go for PN here. You can pick whichever one you want. You can either go for PN or MP, but I'm going to choose PN as long as they both have a point in common. So that is that done. So now I'm going to write out, well, what is M to N? Now I'm going to do this a little bit quick because I don't want the video to be too long. So to go from M to N, we can just go up this way, which is, as you can see, that's going to be 3a minus a half b. So that's that done straight away. If I use my colors like I did before. Now what is P to N? Well, that is just going to be this and then this. So that is going to be sum ratio of the full length AB plus 2a. And now what is BA? That's just going to be that, which is x bracket minus b plus a plus 2a. I'm just going to write that a little bit to the right. And then if you expand that out, you end up with xb plus a x plus 2. We want to write an equation for a and b separately. And again, if I get my colors, so that's your light blue there, okay? So now we are going to write, we can write the same thing again. So we have mn is equal to kpn. So if I use my colors again, if I use the red, we're going to look at a first. So we can say, well, for a, or actually it's easier to do b first. It doesn't really matter which way around you do it, but I'll just do b first actually. For b, so I've just noticed the b equation looks a lot easier to find out x. Well, it'll be quicker, so because it's a bit more clean. So we have minus a half for b is equal to minus, oh, it'll be kx minus kx. So how did I get that? Well, I know that mn I needed b for, and that's got minus a half. And then for mp, I needed b, so that's minus x. So that just ends up with, well, k is just going to be, well, there'll be no negative, then everything just cancel out, so it'll just be a half x is equal to k. So I now know what k is, so I can write the equation for b, for a. So for a, you can then say that, well, we have 3, I'm just looking up there, what I've underlined, is equal to k times x minus 2. I know what k is, so that's just going to be 6x is equal to x plus 2, which means 5x is equal to 2, which means x is equal to 2/5. So this is 2/5, this is 3/5. So it's saying, well, AP is some number times AB, and that essentially is what that is for K. So here's a question for you to have a go at. Press pause and have a go. And as a hint, if you like, I'll give you this hint. The question does say CXE is a straight line. So you're going to use this straight line to find the answer. So I would form an equation for CE and CX, or you could even do CE and XE if you want. So press pause and have a go. Here are the answers. Mark your work. And that is the end of the video. If you would like a full worksheet on the questions we did today, you can get the full worksheet on my website for vectors questions with the answers. And if you are interested in the one-to-one tutoring, you can book that in using the link in the description below or in the comments. And do check out the rest of my videos. And as always, I'll catch you in the next one.